You see, there are two fundamental problems with containers today. First, they suck. I mean, they're just not efficient enough for certain types of cargo. Second, it is very, very difficult to get information either on them or the cargo they transport, which is one of the main reasons for the organizational nightmare the industry is in, and the $200 billion that it represents in waste each year. Our solution to these problems is a new generation of containers. A smart container which not only can load more cargo and significantly reduce the environmental impact of transportation, but one that was designed from the ground up for an autonomous logistics system. And the best thing is that our container economically is a no-brainer. Let me show you why. For example, in the niche market that we first target, the transportation of liquids, so things like shampoo, oil, wine, paint, we can significantly increase the load inside the container to a point that it represents directly $5,000 of additional revenue per year per container over 10, 15 years. So just to put that into perspective, our container only costs about $4,000 more than a traditional one. So you do the math. Add to that the fact that we're putting what the industry wants, which is to be able to follow and to monitor their goods in real time, and you have a recipe for success. And the model is pretty simple. We sell the best container in the world, and we use the vast amount of data that it collects to provide software services that automate operations. So you have a fixed revenue on one side, and then a recurring one over the lifetime of the asset. Let me just emphasize on this because that slide is so important. What that means is that for the trillion-dollar market of containerized freight, if we can convince people to buy our container, which we have, we will know so much about trade that we can automate it. And this is happening right now. We've tested our technologies with some of the leaders in the market, and they were so impressed with the results that we're now negotiating commercial pilots at the end of the year with some of the large customers, which, by the way, are the ones pushing to put their cargo inside our containers because, of course, they want it there because, of course, it's so much better. Now, who are we up against? Well, on one hand, you have traditional container manufacturers, basically steel scrappers, which you can see as the ones making the old car. Then you have dozens of telematic companies, which basically use cheap sensors that they try to put on that old car. You can see them as the TomTom GPS of the industry. We have combined technologies to make a container which is not only twice as good structurally, but that has a brain that is 10 times better than anything you can find on the market. And this is only possible because we combine the IP-protected technologies that we've developed over the years. So if you come back to the analogy of the car, you can kind of see us as the Tesla of the industry. It's not the first time that we do crazy things. One of our mentors, for example, is one of the leading figures of the Solar Impulse project, that $170 million project that made a plane fly across the world without any fuel. Me on my side, I was the co-founder of an industrial IoT company that made smart floorings. My co-founder has revamped internal logistics at one of the largest watchmakers in Switzerland. Our team has sent rovers in Antarctica and digitalized Yatta. So we're ready to take this far and wide. And the milestones that we've set with the capital that we're raising, putting a few hundred containers in the market next year, will be the spark that shows the world that a big change is happening in containerized freight. Now, if you believe that change is happening before they do, then please come talk to me. Thank you. Now, I'm just going to head over there for the computer. As an impressive demo, I will show you the suspenseful arrival of a container, which is pretty much all I can show for the structure of it. But what's important here to note, again, is that that container is loading significantly more cargo. And the things that I haven't mentioned is, for example, the insulation that better protects the container. The fact that you reduce by about 4% the fuel consumption on the road. So there are many, many different advantages that make the asset itself, the structure, a no-brainer. And this is the way that we get that container into the market. But of course, like I mentioned before, what's interesting is also the digital part of that container, right? What it represents in the cloud. And for this one, for example, you have your own little trip that you're monitoring. And the thing that I want you to take note of is that part here on the lower right, because that's where the magic happens. Because what you want to do with one of these assets that is moving is not worry about it anymore. If you really want to automate it, what you will tell people is exactly when something might be happening, when something is going to happen that might be wrong. And those alerts, for example, are not just simple triggers. The point is, depending on the cargo that you have inside the container, to be able to tell people exactly this is rotting, for example. This is going to rot, maybe, or this is going to be in a risky scenario that you might be delayed and you might have this, et cetera, et cetera. And you combine all the sensors to tell you precisely for a certain route, or a certain type of cargo, a certain type of user, what they need to know at a certain point. And this is where really automation can start to happen for the industry. And if you want to have a closer look at, for example, let's say, some of the values from the sensors, you can. That's pretty much pretty normal. And that's it for me. Thank you.
Big round of applause, please. Take a question.
Hi.
Hi.
Really exciting stuff. But just a question. So how much more expensive would this be compared to a telematics-enabled container? Because the margins in the trucking industry are like 1 to 2% EBIT margins, right?
Exactly. That's exactly the problem that the industry has right now. Because you're trying to convince people to buy a telematic tool that has to be necessarily, because you can't put everything inside, so you have to choose, right? For example, you're a pharma company, you're going to buy specifically a temperature sensor to do something. So you might reduce the cost to a few $10 or $100, normally $100, $150, but in the end, you can't use it in the system. And that's the goal here of that container, is that you have everything out of the box and just activate whatever you need. So the thought here is to say, who is the one that is actually the owner of the asset, and is the one that doesn't care actually what is inside. It just wants that thing to be the perfect product for any of his customers. And that's a little bit the mismatch. The other one is, so it is definitely more expensive, but we absorb the cost of the electronics through the advantages of the structure. And that's where actually things happen. Like currently, our customers are not buying this as a main focus to say, oh, we understand everything about digitalization, and this is why we're buying it. It's a little bit like in the beginning in the Tesla, you're buying it because it's an electric car, because you want to reduce your environmental footprint, but not because you necessarily want an autonomous car. That comes afterwards. So it's a little bit the same thought process.
So who's your customer? The freight forwarders?
Exactly.
Or
in the beginning,
the freight forwarders?
Yeah, in the beginning, small owners that are typically freight forwarders that have what we call SOCs, so shipper-owned containers, so small fleets. And then afterwards, once you have a loop that is working, so those guys, for example, they have certain customers that they can run in a loop. You know, let's say Procter & Gamble that ships things from the UK to South America, and then a winery that sends something back. And they can really maximize the value of the assets in these loops. Once these loops are created, then the shipping lines can come in because they can see also the value of getting a fleet that is in the couple of thousands that they can also upsell to those same customers that have already validated the model.
Any? Yeah.
So you are producing the containers, or you are working with some partners?
We are working with partners. So we have the designs, and some of the capital that we're raising right now will be to continue to apply patents, because it's actually a blue ocean. Like the combination of the technologies that we've made are pretty much not existent, especially in that sector. But we will outsource to certain specific partners on the composite side, on the steel side, and then on the assembly side, pretty much like Apple and Foxconn, kind of relationship.
Thank you. And how long does it take for a container to be built and shipped?
To be built and shipped. So building a container is going to take around a day. That's so in the end, the cost that we can get it down to, if we at the level where we have a few tens of thousand containers, is approximately 4.5K, everything included, electronics, et cetera, et cetera.
Thank you.
Do you know how many containers are bought annually?
So of the 20-foot containers, about 1 million. In total, if you think of TEUs, so 20-foot equivalents, it's about 3 million.
A year?
Yeah.
I have no question.
Fantastic.
Just holding the mic. Is your container shipped in another container when you get it? It's delivered.
No, it's not. It's like typical containers. You have to try. Actually, logistically, it's actually a good question, because it will definitely be important in terms of the decision of where we build them, because our customer base will definitely have an influence on where we build them to avoid that initial logistical cost.
How do you ensure the service of the broken electronics?
Sorry?
How do you ensure the service of the broken electronics?
So that's actually a pretty important point, and it's again coming back to the advantage compared to a normal electronics. We've designed the electronics actually to be maintenance-free, sort of, avoiding like the occasional breaks, but to be maintenance-free for the entire lifetime of the asset. So it actually recharges itself. You don't have for the entire 10, 15 years to do anything with it, and you have real-time connectivity on it. So And then if you actually have to service them, then you go through the service centers of the ports usually. So they have maintenance sites in ports where we will have to do some training, or in the beginning maybe chase a few of the containers while we don't have still a fleet that is big enough.
Quick question. Did you think about a license model with an existing manufacturing and pro and cons?
Yeah. So the cons is that they're still like scrappers. It's like literally they just take old steel, hammer it down with cheap labor, and they make panels of it. So like waiting for them, and the technologies that we're using are quite cutting edge. And like even in most sites, you don't really have necessarily the knowledge to make this big manufacturing sizes with composites especially and so on. So getting them to have composites manufacturing established and so on, it's way off, especially with the history that they have and that side. But we do use them as partners for now the frame. Actually the frame that you see here, it's a little bit our Tesla Roadster right now. So we use an existing frame of a container and we put whatever minimum technology we have to bring the maximum advantage to the container. So we do use them as partners for the frames and they're excited about that.
Great. Thanks a lot. This was Aeler. Big round of applause, please. Awesome.